Okay, so good morning, class. So welcome back. So we are discussing about stresses in soil. Okay, so this will be the probably the last class. Okay, so we already discussed plenty of things in this chapter. Okay, so like Bosnius theory we discussed, and Westergaard's theory we discussed, and what is the difference between Bosnius and Westergaard also we have seen. And see these for different kinds of loading, like concentrated load, like circular load, rectangular load, or those loading conditions, how to determine the stress in the soil at any point. Okay, so those things also we have discussed, and at the end we have discussed even Newmark chart also. Okay, so and also we have gone through this foundation settlement. Okay, so we told that in the settlement we have three types of settlement. One is the immediate settlement, okay, or elastic settlement, and then we have consolidation settlement, and then we have a secondary consolidation settlement. Okay, so as we discussed in our previous lecture, elastic settlement or initial settlement, immediate settlement are very important for the sandy type of soil, okay, like coarse grained soil. Okay, so this consolidation settlement is more prominent in clay type of soil. Okay, so and also we have seen how to find out the settlements. Okay, so like for example immediate settlement. Hmm? So till here we discussed it in our previous class, right? So whatever these settlements are there, no, these are depending on the they are dependent of your footing stiffness as well as the type of soil. Okay, so as we saw in our previous class, if we have a flexible foundations, if you have a flexible foundation, what will be the cases? Hmm? So if you have a flexible foundation, if you have a flexible foundation, our settlement profile will be varying. Okay, so see the settlement is varying here. Okay, so in case of clays and in case of sand, but whereas the contact pressure is uniform. Okay, you see the contact pressure, it is uniformly distributed. Okay, so if you have a flexible foundation, okay, what are the example for flexible foundation? Like your raft foundations. Okay, so those things all can be designed with by considering the flexibility of the foundation. Okay, and the next kind of foundation are the rigid foundations. Okay, so in the rigid foundation, what will happen? Your settlement will be constant. Okay, so settlement profile will be uniform. You see the settlement profile here. If it is settling by around some 6 mm means it will be settling same thing. 6 mm will be present in the all the direction. Okay, so in all the length, throughout the length of your footing. Okay, so that is the case where the rigid foundations will be. Okay, so in the rigid foundation case, we have the uniform settlement, but the contact pressure, you see, if you see the contact pressure, it's not uniform. Okay, so it's varying. So at the edges it will be more in sand, sorry, it will be more in clays, and at the center the contact pressure will be smaller in clays, whereas in sands at the center the contact pressure will be higher, and at the edges contact pressure will be lesser. Okay, you see the contact pressure here, at the edges it will be lesser, and at the center it will be higher. Okay, so what is the example for rigid foundation? Your isolated footing. Okay, so your isolated footing can be designed as a rigid foundation. Okay, so here are the few examples. You see, this is the isolated column footing. Okay, so why it is called isolated? Because only for it is supporting only one column. So this is the column, and this is the foundation, right? So this is the foundation. So isolated means only one foundation is supporting one column here. But here you see this is the combined footing. Okay, so this is one column and another column supported by this one foundation. Okay, so this kind of footings are called as combined footing. Okay, so in the combined footing, it may be rectangular footing, or it may be trapezoidal footing, or it may be square footing. Okay, so depending on the availability of space, you can decide, or the load coming on the foundation, you can decide what kind of shape you require. Okay. Okay, so now coming to the elastic settlement. Okay, so how to find out the elastic settlement? Okay. So as I told, elastic settlement, it is important or prominent in what? Which kind of soil? Oh, it is prominent in what kind of soil? Sandy type of soil. Okay. So what are the assumptions here? The soil is elastic and infinite thickness. Okay, so and a specific foundation geometry and stiffness. Okay, so the foundation, whatever the stiffness is there, no, that the foundations and geometry they have for a particular type of geometry. Okay, so for rectangular or circular flexible footing on a thick homogeneous layer extending below the foundation to a considerable depth, then we should use this is the formula to use. So what is the formula? Immediate settlement SI is equal to Q times your width of the footing into 1 minus your Poisson's ratio divided by Young's modulus into the influence factor. Okay, so this formula is important. Okay, so you should remember this formula. In exams, many times the the problems have been asked based on this formula. Okay, so they will give you your Poisson's ratio and Young's modulus and the breadth of the footing and the intensity of loading they will give you, and also the influence factor they will give. Okay, only straightforward problem here. Simply we have to substitute and get the answer. Okay, so settlement you will get. Okay, so this settlement will be in terms of mm or in terms of meter you can represent. So note that the vertical displacement increases in direct proportion to both the pressure and the it's not width and the width of the loaded area. Okay, so let me correct here. Pressure and the okay. So you see this SI is there. No? This SI is directly proportional to what? It is directly proportional to the intensity of loading and your width of the footing. Okay, so Q and B. So if you increase the intensity of the loading, then your settlement also will increase. And if you increase the width of the footing, and your settlement also will increase. Okay, so because they are directly proportional here. So what is Q? Q is the net foundation pressure. Okay, so this Q is the net foundation pressure. This will be in terms of kilonewton per meter square. Okay, and B will be the width of the foundation. So your B will be the width of the foundation. Then what is mu? Mu is the Poisson's ratio, and E is the Young's modulus, and IF is the influence factor for a settlement. Okay. Okay. So, however, if layer thickness is less than twice the breadth, an overestimation of settlement will result from the above equation. Okay. So, if you see here to use this equation, there is a condition. What is the condition here? You see this is the condition. Okay, so like thick homogeneous layer extending below the foundation to a considerable depth. Okay, that means you have only one layer. Okay, so this is your soil, this is your ground level, and only one kind of soil layer is there. Okay, so like if you have a sand, okay, so this sand may be extending like for a larger depth, maybe like 5 meter or 6 meter or 10 meter. Then only this formula is applicable. Understood, no? So see, in nature, it's not possible that you will find only one type of soil. Okay, so you will be having different layers of soil. Suppose sand, if you have a sand, layer 1 as a sand, then it may be layer 2 as some layer 2 some clay type of soil. So this is layer 1. Okay, so this is how we will get in the field condition. But this equation is applicable only if you have only one layer of soil extending for a larger depth. Okay, so but if you use the same equation for this kind of soil profile where you have a different soil layer, then whatever results you will get, so they will overestimate your settlement. Okay, but what to do if you have if you have a different soil layers, then what should I do? So I have to use this equation. So this is the equation applicable for layered soil. Okay, if you have a different soil layers, then you should use this equation. So, but in the exam, okay, so in the exam, till now, whatever question papers I have referred, they always given the problems based on this equation. Okay, so if you can able to remember this equation, then it will be more than sufficient to calculate the immediate settlement. Okay, so this is more important. Okay, but what is the limitation of this equation? The limitation is if you have a layered soil profile, then if you use this equation, you will overestimate the settlement. Okay, but if you overestimate the settlement, anyway, it is on the safer side. Okay, so even if you use this equation, there is not going to what do you call failure, I can say. Okay, so because you are always overestimate the settlement. Okay, so you will be on the safer side. Okay, so if you overestimate, then you will try to reduce that settlement by playing with the dimension of your footing. Understood? Okay. So see, this influence factor is there, this IF. It is a function of your shape of footing. Okay, so that is L by B. So your influence factor, see here table is there. This table is taken from your IS 8009. So 8009 in IS code, in that IS code, they given these influence factor values. Okay, so if you have a circular type of footing, and if you want to calculate the settlement at the center, then this is the influence factor you should use. Okay, if you want to calculate the settlement in the corner, then this influence factor you should use. Okay, so if you want to calculate average settlement, then this influence factor you should use. Okay? So for square footing at the center, this is the influence factor. So at the corner, this is the influence factor, but average influence factor is 0.095. Okay, so for rectangular foundation, for a different L by B ratio, you can use these influence factors. Okay, so this is another same table only. This is the same table, but taken from different source. Okay, so there is a book called Soil Mechanics by Craig. In that book, they given this table. So in the examination, what they will give? They will give directly this influence factor. They will give this directly, this influence factor. If you are asked to find out the settlement at the center of the footing, then they will give corresponding influence factor. Or if they ask you to find out the settlement at the corner of the footing, then they will give you the corresponding influence factor. So anyway, this formula is not required for your examination point of view, but for the practice point of view, I have put this equation. This is more a realistic equation. But if you don't want to remember, you can skip this formula. But, this is just like extra, because whatever question paper I have referred, they all ask the questions based on this formula. So you can skip this slide if you want. But this slide will be very important once you start your career. So there is a difference between the exam point of view and your practice point of view. So in practice, we will use this formula. Okay, whenever you become a consulting engineer in the later stage of your career, so then what will happen? So at that time, you should use this formula. So mu naught into mu1 into QB by U. What is mu naught and mu1? So mu naught is the coefficient function which is a function of a d by b ratio. That is, d means your depth of the footing versus your width of the footing. And mu1 is the coefficient function which is a function of h by b and l by b. Okay, so mu1 you will get from this graph. Okay, so mu1 you will get from this graph, and mu naught you will get from this graph. So for d by b you get mu naught, and for h by b and for l by b, for h by b and l by b you will get mu1. Once you get mu naught and mu1, anyway, thickness of the foundation layer is there. This is the thickness of foundation layer, and d is the depth of the foundation base, and E is the Young's modulus. Simply you substitute in this equation, you will get the initial or elastic settlement or immediate settlement. So, but from the exam point of view, this is the formula important. This formula is very important from exam point of view. From exam. Okay. So, okay, let's try to solve this problem. Okay, so then whatever this theory is there, this formula, based on this formula, I have put an example here. Okay, so what is this example? So a flexible foundation, 4 meter by 2 meter, carries a uniform pressure of 150 kilopascal. Okay, so this is your foundation. Okay. So this is my ground level. Okay. This is my this is my depth of footing. What is the size of footing? 4 meter by 2 meter. 4 meter by 2 meter is your foundation size. And what is the load applied? What is the load applied here? 150 kilopascal. Okay, so your Q is equal to 150 kilopascal. Near the surface of soil mass. So what is Young's modulus they given? Young's modulus of soil 40 MPa. And this is mu, Poisson's ratio. So mu is equal to 0.5. So determine the settlement at the center, they are asking. Okay, so determine the settlement at the center and the average settlement of the foundation, they are asking. Okay, so two cases here. Case one is at the center of the footing. At the center of the footing, they are asking. Case one. Center. And case two, what is the case two? They are asking average. Okay, so average settlement, like for all the 2 meter width, what is the average settlement they are asking? Okay, so let us start with case one. So for case one, what is the formula? So formula, if you remember, my elastic settlement is equal to Q into B divided by E into 1 minus mu square into the influence factor. Okay, so Q is how much? Q is 150 kilopascal. What is width of the footing? 2 meter. So and what is the Young's modulus of the soil? Young's modulus is 40 megapascal, 40 MPa. Okay, so see, Q is in kilopascal, no? So then I have to put even E also in kilopascal. So that means 40,000 kilopascal. 40,000 kilopascal. Okay, and mu is 0.5. So influence factor IF is there. No? This influence factor is a function of what? L by B ratio. No? So take L by B ratio. So for L by B ratio is 2. So the influence factor at the center is 1.52. Okay, so if you refer to that table, for this is a rectangular footing, no? So this is a rectangular footing. My L by B ratio is how much? 2, no? 2, right? L by B is 2. Okay, so for the 2 at the center, what is my influence factor? 1.53, and at the average is 1.31. Okay, so coming back 1.53, 1.31. Okay, so this is 1.52 and 1.3. Simply substitute the equation, then you will get the answer. Okay, so for at the center I got 8.5 mm settlement, and at the average settlement is 7.17 mm. So only thing you have to remember the formula. Okay, then you get the L by B ratio and refer to that table. Okay, so but in exam anyway, you need not to worry about this L by B, because they will give directly the influence factor. Okay, so otherwise if they not give the influence factor, what they have to give for different L by B combination, they have to give the influence factor. This influence factor should be provided, then only we can able to calculate the settlement. Okay, so many exam question papers I have seen, they will give you directly the influence factor. Okay, so if they give directly the influence factor, simply you substitute and get the answer. So this is about your elastic settlement. Any doubts here regarding elastic settlement? Nikhil Rodgi?
Sir, no doubts.
No doubts. Okay. Sandeep Backward?
No doubts, sir.
Okay, understood. No. So what we discussed till now, we discussed how to calculate the elastic settlement. Okay. So to calculate elastic settlement, I have to remember the formula is that Q is equal to elastic SC is equal to Q into V into 1 minus mu square divided by your Young's modulus multiplied by the this one influence factor. Okay, so only thing influence factor, how to find out the influence factor? Influence factor is the function of your length and breadth. Okay, so based on length and breadth, and based on the shape of your footing, if you have a circular footing, or if you have a rectangular footing, or if you have a square footing, then they will give you the influence factor at the center, at the corner, and the average influence factor they will give. Okay, so based on that you can calculate. So this is the table. But in exam they will give directly these influence factors. Okay, so one examination question paper question we will see here. Then you will appreciate that equation. I think this is the problem. Okay. You see this one? This problem asked in 2017-18, just for 4 marks, because it's a very small problem. So weightage also very small here. Okay, so what they told, reinforced a concrete foundation of dimension 1.8 meter by 3.6 meter. Okay, so let me draw that foundation here. Okay, so what is the dimension of the footing? 1.8 meter by 3.6 meter. Okay, so 1.8 by 3.6 meter. So this is my, maybe this is the ground level. No? This is my ground level. Exerts a uniform pressure of 180 kilonewton per meter square. Okay, so what is my Q value? Q is equal to 180 kilonewton per meter square. And a soil mass with a Young's modulus of 45 meganewton per meter square. Okay, so what is the Young's modulus here? 45 megapascal. Determine the immediate settlement under the foundation and take mu is equal to 0.3. What is the Poisson's ratio they given? 0.3, and influence factor IF is 1. So influence factor is 1. So what is the formula? Tell me. SE is equal to, what is the formula? Q into Q into B divided by your Young's modulus into 1 minus mu square into your influence factor. Okay. So what is SE? Q is 180 kilonewton per meter square into your width of the footing. Width always you should take the small dimension. This is my width and this is my length. So 1.8 meter divided by Young's modulus. Young's modulus is 45 megapascal. Okay, so 45. Since see, this is in kilonewton. This is in kilopascal. Okay, so I have to put this also in terms of kilopascal. That means 45,000 kilopascal into 1 minus 0.3 square into what is the influence factor? The given 1. Calculate how much. Tell me the answer. How much?
6.55.
6.55. This much only. How much? Into 10 to the power of something which should be there, no? Yeah.
6.55 into 10 raised to minus 3.
10 raised to minus 3. What is the unit here? In what unit I will get?
Meter.
Meter. Because see, this kilopascal will get cancelled, no? So anyway, mu is unitless and influence factor also unitless. The only thing, whatever with what unit you are putting, the same unit you will get. So 1.8 meter I am putting the same unit meter in terms of meter only I will get. So that means 6.55 mm. So if you want to put it in, just you remember the formula and substitute. One thing we should be careful in what unit they are giving Q value and in what unit they are giving your Young's modulus value. Both should be in same unit. Okay. So this is about your elastic settlement. Okay. So next we'll go to consolidation settlement. Okay. Now we will discuss this consolidation, that is SC. Consolidation settlement. Okay, so you see this picture. So this is a picture from Mexico City. Okay, you see in 1911. In 1911, you see the this monument. So I want to draw your attention between these steps. So in 2000, you have this much settlement because this structure is standing on the pile foundation. So this structure is standing on the pile foundation. Pile foundation means we have small piles which will rest on the hard strata. Hard rock strata will be there. Okay, so over that it will rest. Okay, and if you see the surrounding soil, the surrounding soil has been settled. Okay, so this will be around some 2 to 3 meters. It has been settled. 2 to 3 meters. This much settlement will be there. So that settlement is because of this consolidation settlement. So over the years, what will happen? They have drilled a lot of boreholes here inside because as the city grows, the water requirement will increase. No, So what will happen? All the people will start drilling a lot of boreholes. Once with a lot of boreholes, what will happen? A lot of water you are pulling out from the ground. So once you pulling out the water, what is happening? So consolidation settlement will occur. This is the example for the consolidation settlement. Okay, so how to calculate this settlement? The settlement, how to calculate? So for that, we should know this consolidation theory. Okay, so in the previous semester, we have a chapter called consolidation. In the 5th module, I think, in your previous semester, basic soil mechanics. There we have studied two concepts. Okay, so in the consolidation settlement, there are two important parameters. One is, where should I write? Let me write here itself. So there are two important theories. Sorry, what we call two important parts, I should say. Okay, so two important parts in the consolidation settlement. Okay, so one is how much settlement will occur. And the second one is, can anybody tell me? Because I think I taught some of you in the previous semester. So how much settlement will occur and how fast this settlement will occur. Okay, so how much? See, this for to calculate the settlement calculation, I need if I can able to answer this question, that will be sufficient for me. Okay, so how fast for time being we won't bother. Okay, so let us don't bother about this how fast the settlement will occur, but now we will stick to how much settlement will occur. Okay, so there are 4 important parameters we will obtain in the laboratory. So what are those 4 important parameters? One is the coefficient of compressibility. That means, see, if you have a ground like this, if you have a ground like this, and if I want to find out the suppose this is a clay. This is a clay of thickness some 10 meter. So if I want to find out the consolidation settlement in this layer, what I have to do, first I have to collect the soil sample from this area, and then I have to do some consolidation test in the laboratory, and then I should arrive at these parameters. One is, first parameter is the coefficient of compressibility, that is AV, and compression index, okay, that is CC, and MV, okay, that is the coefficient of volume compressibility. So these definitions are very important to calculate the settlement foundation. I'm sorry, consolidation settlement of the foundation. So what is the first parameter? Coefficient of compressibility. What do you mean by that coefficient of compressibility? That is nothing but change in White's ratio to the change in effective stress. Okay. And what is the compression index? The compression index is same parameter, but now whatever your effective stress is there, that effective stress is plotted in the logarithm scale. Okay, so in the logarithm scale, if you plot, then your coefficient of compressibility becomes compression index. If you take the ratio of your change in White's ratio to the change in effective stress, and then coefficient of volume compressibility. What do you mean by coefficient of volume compressibility? That is MV. MV is nothing but AV divided by 1 plus E naught. And when you perform the consolidation test, when you perform this consolidation test in the laboratory, you will get this kind of graph. Okay, so that means you have to plot a graph between your White's ratio versus your effective stress, the vertical effective stress, that is sigma dash. So once you start what you will do, once you apply the load, this White's ratio will keep on reducing. Okay, so as you apply the load, the White's ratio keep on reducing, and then at one point, see here, the slope is different here. This portion, the slope is different, very shallow slope. Now, once after this point, the slope is now, you see, very steep here. This is very steep slope, and this is very shallow slope. So wherever this slope will change, that is called as pre-consolidation stress. Okay, so PC I will call this point. So that is called as a pre-consolidation stress. That pre-consolidation stress is nothing but this is the maximum stress historically the soil ever experienced. Okay. So the slope of this portion of the curve is CR. That is called as recompression curve, and slope of this portion of the curve is called CC. Okay, that is called what do you call this? CC is nothing but a compression index. So this is the compression index, and this is the recompression index, or swelling index also you can call. Again, up to this point, I'm keep on increasing my load. Then after reaching here, I will keep on removing the load. What will happen once I start removing the load? It will swell here. It will swell, and then I will once again I will add the load. Then the curve follow like this. Okay, so again this slope of this line is called as recompression slope, or recompression index also you can call. So this is how we will see. This is how we will obtain the stress strain curve for the consolidation test. So these are the important definitions you should remember. The most important thing is this one, CC, because while calculating my consolidation settlement, I have to use this formula, CC. Okay, once we perform this consolidation test and obtain this these parameters, then next thing is some terminology I should remember. What are those terminology? So what do you mean by normally consolidated clay, and what do you mean by over consolidated clay, and what do you mean by over consolidated ratio, and what do you mean by this pre-consolidation pressure? Okay, so these are the few definitions you should remember. So normally consolidated clay means the present effective overburden stress is the maximum pressure that the soil has been subjected in the past. That means my pre-consolidation stress is equal to the present vertical stress. So that kind of soils are called as normally consolidated soil or clay. And what do you mean by over consolidated soil? The present effective overburden stress, whatever present effective overburden stress is there, this is less than that which the soil is ever experienced in the past. Okay, that means your pre-consolidation stress. Okay, so your present vertical stress is less than my pre-consolidation stress. Okay, that kind of soils are called as over consolidated soil. So let us take one example here, and there I will discuss practically. I will discuss how, when you will call a over consolidated and when you will call a pre-consolidated soil. So let me. Here so here this is my ground level. This is my ground level, and I have a 5 meter deposit of clay. So this is some 5 meter clay is there. So this clay, and its unit weight is something around 20 kilopascal. Dry unit weight. Let me take it as a dry unit weight. Okay, there is no water table. Okay, now you tell me what is my stress present at this level. What is my stress here? So that is sigma V naught dash is nothing but simply 5 into 20. 5 into 20 around then 100 kilopascal. Hmm? So this is V naught. Hmm? So this itself is the pre-consolidation stress, sigma P dash. Okay. So pre-consolidation stress is nothing but the soil. It is the maximum vertical pressure in the history the soil has ever experienced. Huh? So in its throughout history, how much stress it has experienced? 5 times around 20. Okay, that means 100 kilopascal. Okay, so that is my pre-consolidation stress. Now I will come and I will build a structure here. Hmm? Some 3-floor building I will build here. Hmm? So this is my footing here. Huh? So this may be some 3-meter depth. In the 3-meter depth, and remaining depth is how much? 2 meter. Okay. So this is first floor, this is second floor, and this is third floor. Sorry, first floor, second floor, third floor. Okay. So now I want to calculate the stress here. Hmm? So my sigma V naught dash is equal to whatever your due to this soil some stress is there. Okay, so that is 2 into 20. Okay, around 40 kilopascal. Hmm? So 40 kilopascal plus uh, plus plus what the stress induced by this structure. Okay, so let me call that as some 60 kilopascal. Hmm? So that means around 100 kilopascal it is subjected. Hmm? So this is the present stress. Hmm? This is what this is past stress. Past stress. Okay. So your present stress, whatever is there, this present stress, it is almost equal to your past stress. Okay, so this kind of soils are called as NC soil, normally consolidated soil. Okay, why it is normally consolidated soil? Because whatever the present loading is there, no, the present loading is almost equal to your past loading. Hmm? What was my past loading? Around 100 kilopascal, and what is my present loading? Again it is same 100 kilopascal. So if both are same, then my this kind of soils are called as NC soil or NC clay also you can call. Okay, normally consolidated. So normally consolidated clay or soil, simply you can call it as a soil. Okay? Now this is my ground level, and this is my 5-meter depth. This is my 5-meter depth, and here I want to find out my stresses here. Hmm? Here I want to find out the stresses here. Okay, so what is my sigma V naught initial stress? 5 times 20. Okay, so that is 100 kilopascal. Hmm? Now, now what I will do? I will come and build a structure here. Very small structure I will build. Okay, so only one store building I will build here. Hello, all of you there? Some network issue came, I think, in between. Hello, can anyone?
Yes,
Yes,
sir.
sir.
Can anyone tell me when the connection is lost? Spurti,
Sir,
when the connection is lost, whatever I explained, are you able to listen that? Because I got a message that someone told me I have left the meeting. Maybe that was because of some connection issue. So all of you can able to understand the difference between the NC soil and OC soil?
no, sir.
Okay. Okay, so I will straight away go to the formula here, because see, there are 4 ways to calculate the consolidation settlement. So see, you need not to remember all these formula. I will tell the point where you should remember the formula. So first formula to calculate the consolidation settlement is this one. Okay, delta H by H naught is equal to delta E by 1 plus E naught.
Sir, you haven't shared the screen.
Okay. Sorry. I think in meanwhile I got some connection problem. Sorry for that. Okay, now are you can you able to see the my screen slide?
Yes, sir.
Okay, so see, from exam point of view, now you should remember only one formula, not all these 4 different formulas, but there are 4 different ways to calculate the settlement. Okay, so first equation is by using your basic equation, delta H by H naught is equal to delta E by 1 plus E naught. Okay, and my delta H is nothing but my consolidation settlement. Okay, so if you take my consolidation settlement, delta, this is the change in voids ratio to the initial voids ratio into the thickness of soil layer, H naught. So then second way to calculate is either by using your coefficient of compressibility, or even you can use your volume compressibility, that is MV. But no need to remember these formulas, but this formula is important. This one you should remember to calculate my consolidation settlement. So how you will calculate the consolidation settlement? So SC is equal to H into H divided by 1 plus E naught CC into log of sigma 1 dash divided by sigma V naught dash. So H is what? H is your compressible soil layer. Compressible soil layer. And CC is my compression index, and sigma 1 is nothing but my in situ stress plus a change in stress due to external loading. Okay, so this is the in situ stress and this is my change in stress. Both together I will call it as a sigma 1. Okay, sigma 1 dash divided by sigma V naught. Sigma V naught is existing effective stress. So this CC is there. Now this CC can be find out by using some by using the liquid limit test. If you would have performed liquid limit test, you can find out the CC. Okay, because see, this CC, even you can, if you want a very accurate CC, then what you have to do? You have to do the consolidation test. Consolidation test. So this consolidation test is very time consuming. Okay, so it requires around 10 to 15 days. So it is a very long process. Okay, so 10 to 15 days spending time, it will be very costly affair to find out this CC value. Okay, so that's why previously many researchers, what they have done, they have done they have established some relations between your CC value and some index properties. Okay, so this liquid limit is just half an hour test it is. Maybe less than half an hour, maybe 10 to 15 minutes you can perform. Once you perform that liquid limit test, you can get CC value here. So this is the for NC clay. Okay, so now for time being, don't bother about whether it's NC or OC. Okay, so because in the examination always they will ask for NC clay only. So you remember, if you remember this formula, that will be sufficient to calculate the consolidation settlement. So let us solve some problem based on the consolidation settlement. Okay, so this is one problem. See, this is the soil layer. This is a clay type of soil, and its depth is 4 meters. And over this soil, this is my ground level. This is my ground level. Over this soil, I have put some soil fill. I have put. Okay, so this is some soil fill. Soil fill. Okay, so this thickness is around 2.5 meter. Okay. Okay, so if you recall that formula, what is that formula? Here you see SC is equal to H by 1 plus E naught CC into log of sigma 1 dash divided by sigma naught dash. So now I have to calculate first the sigma naught. See, always I have to calculate at the center of this clay layer. This 4 meter means I have to calculate at the center of this clay layer. So that means here at 2 meter depth. So at 2 meter I have to calculate at 2 meter I have to calculate sigma naught dash and delta sigma dash. Delta sigma, in the formula I use delta sigma. This is nothing but your delta sigma z. Okay, so how to calculate this delta sigma naught dash? The sigma naught dash is nothing but your initial stress. So this initial stress is nothing but 2 into your unit weight of soil. So unit weight of soil is saturated unit weight is 15 kilonewton per meter square, but I have to calculate the effective stress. Okay, so to calculate the effective stress, I have to deduct this unit weight of water. So this is the unit weight of water, and this is the unit weight of saturated soil. So I got 10 kilopascal sigma naught. Sigma naught is around 10 kilopascal. And what is my sigma 1? Sigma 1 is nothing but sigma 1 dash is nothing but my sigma naught dash plus delta sigma z. So sigma naught is how much I got? 10 kilopascal. And what is my delta sigma z? Anyone can tell me what is my delta sigma z at this level? If you remember, if you have a very large loading area on the ground, then your delta sigma z is equal to the weight of this fill. What is the weight of this fill? So 20 times your height, 20 into 2.5 times. That is my delta sigma z. Okay, so 2. Around 50 kilopascal. Okay, so if you combine both, then I will get a 60 kilopascal. So CC anyway they given 1.2. CC they given, and the White's ratio also they given. White's ratio of this soil also they given, and my compression index also they given. So simply you substitute and get the answer. So this is the 1.48 meter is my consolidation settlement. Any doubts here? So anyway, so I will solve some examination problem. Then you will appreciate this usage of this equation. Okay, so coming back here. This is 9, this is 10. Okay. So let me start with some easier problem. Okay, so this is a little bit easier. Then I will solve these problems. Okay, so this problem you see what they are telling. A square footing 1.2 meter by 1.2 meter rests on saturated clay layer of 4 meter deep and whose liquid limit is 30% and saturated unit weight is 17.8 kilonewton per meter cube and water content is 28% and specific gravity is 2.68. Determine the settlement of the footing which carries a load of 300 kilonewton. So let us draw that first. Always try to draw the figure, then it will be easier to solve the problem. So this is my column and this is my rectangular footing. Okay. What is the size of my footing? So this is 1.2 by 1.2 meter and this is my ground level. This is my ground level and it is resting in a clay layer of 4 meter deep. So this is something square footing 1.2 meter by 1.2 meter rests on a saturated clay 4 meter deep. Okay, so this is 4 meter. And what is the liquid limit of this clay? Liquid limit is 30%. And gamma sat, that is saturated unit weight, is 17.8 kilonewton per meter cube. And what is the water content? 28% is the water content and specific gravity is 2.68. Okay. So determine the carries a load of 300 kilonewton. Okay, what is my Q value here? 300 kilonewton. Okay. Okay. So what is the formula? Tell me. Consolidation settlement. SC is equal to H naught divided by 1 plus E naught into CC into log of my sigma V naught dash plus delta sigma divided by sigma V naught dash. Okay. So first, let me calculate my sigma V naught dash. Sigma V naught dash. So always, as I told you, you have to calculate at the center of the clay layer. Okay, so this is the 4 meter. No, so see, actually they should give this depth. Okay, they're not given this depth. Okay, for time being, don't bother about this one. Okay, so let me take this the center. Okay, so here I have to calculate my sigma naught dash. I have to calculate it, and delta sigma also, delta sigma z also I should calculate. Okay, so this is delta sigma z I will call. Okay, now you tell me what is my sigma V naught at the center of the clay layer. This is simply 2 meter is the depth, and what is my unit weight? 17.8. Okay, so I have to take the effective stress, so I have to deduct it in the unit weight of water. So 2 into your 17.8 minus 9.81. Okay, so that is your saturated unit weight minus your unit weight of water. Then I will get a what I will get submerged density. Okay, so submerged density into your depth will give me your effective vertical stress. Okay, tell me what is the answer? Sigma V naught dash. How much? Hmm?
15.98.
Yeah, 15.98 kilonewton per meter square. Now I have to calculate my delta sigma. Delta sigma z. See, to calculate my delta sigma z, see this sigma naught is there. No, this sigma naught is nothing but before putting your footing. What was my stress I have calculated here? Okay. Now due to delta, this delta sigma is nothing but the increase in stress because of my footing. Okay. So to calculate that one, I have many options. Either I can use a Bussner's theorem, or I can use a Westergaard theorem, or I can use the approximate method. Okay, so let us use the approximate method. Okay, so this is my Z. So this Z will be, let me take it as a 2 meter, because they're not given this depth, no. So that's why now it will become problem for me to calculate this Z value. Okay, so assuming this value is around 2 meter, and so then now my Z is 2 meter. Okay, so your delta sigma Z is equal to whatever the loading is there, no, that divided by my area. So if you remember that formula, what is my delta sigma Z? How to calculate delta sigma Z? Approximate method. You see, no? One more formula is going here. Yeah. So here delta sigma Z is equal to my load divided by this area, effective area. E plus Z into L plus Z. So 300 kilonewton divided by effective area. What is my effective area? See, this is 1.2 meter. Z is how much? Z is 1 meter. Okay, so 2:1 ratio. If you take then this half of my Z will be here. That is Z by 2, and half of see, this is my Z by 2. So Z by 2 plus my width. So 1.2 plus here 1 meter and here 1 meter, right? So that means around 3.2 meter. 3.2 is my width, and length is also same 3.2. So delta sigma Z, how much you tell me? Hmm?
29.29.
So around 29.29 kilonewton per, yes. So this is my delta sigma Z I got. Okay. So once I got this one, next I have to find out my CC value here. So how I can calculate the CC value? If you remember the formula, CC is equal to 0.009 your liquid limit minus what? 10. So this liquid limit, you should put it in terms of percentage. Huh? So 0.009. How much liquid limit I got? 30%. 30 minus 10. Tell me what is the CC value? CC value is something around 0.18. Okay. So once we got the CC value, next what is the other parameter I should find out? This initial voids ratio. This also I don't know, right? So from your previous semester index properties, there was a formula this called SE is equal to W into GS. You remember this formula? Hmm? So that means for see, anyway, the water level is at top. They are telling, right? So here they are telling the water level square footing. Anyway, they are telling this is a saturated clay. Saturated clay they are telling. So saturated means S is 1. So E is equal to W into GS. So what is the water content here? 28%. 0.28 into specific gravity. What is the specific gravity? 2.68. So what is the E value you are getting?
0.7.
Or E naught, for example, E naught 0.75. 0.75. Okay. Now, so all the parameters you got the White's ratio, you got yours. Okay, now what you have to do? Simply substitute in this equation, you will get the answer. So my SC is equal to, what is the formula? H naught. What is the H naught? H naught is nothing but the compressible layer of the soil. What is the compressible layer here? 4 meter. So 4 divided by 1 plus E naught. 1 plus 0.75 into CC. What is CC? 0.18 into log of my sigma naught. That is initial vertical stress. How much? We not here. How much you got here? Sigma we not around 15.98. 15.98 kilonewton per meter square. Okay, so that is my sigma V naught. I here I written not, sorry. But I am not capable of this. I written here. I will leverage it. Okay, so 15.98. And what is my delta sigma? 29.29. Right here. 15.98 plus 29.29 divided by your initial vertical stress. Initial vertical stress is 15.9. So tell me, what is my consolidation settlement? How much?
Point 18.
0.186. What is the unit here? Meter. So if you want to convert it into mm, then 186 mm. So 186 mm is a very big amount. Okay, so usually 60, 50 mm is the allowable limit. That means the settlement is more here. Okay. So let me solve this problem. it is also 2016 for 12 months they asked. So let me solve this one. Uh, the soft normally consolidated clay layer is 18 meter thick. Okay. So first draw the figure. Meter thick. The natural water content is 40%, 45%. What is W is equal to 45%. So this H naught, that is the thickness of the compressible clay layer. Okay, so natural water content is 45%. The saturated unit weight is 18 kilonewton per meter cube. Okay, so gamma sat 18 kilonewton per meter cube. Okay, the specific gravity is 2.7. Specific gravity 2.70. And the liquid limit is how much? Right here. Liquid limit is 63%. The vertical stress increment at the center of the clay layer due to the foundation is 9 kilonewton per meter square. Okay, so they are giving the delta sigma z directly. Okay, so this is 9 meter. Always at the center, we should calculate. This is 9 meter and this is 9 meter. Because total is 18 meter. Okay, so the vertical stress increment at the center of the clay layer due to the foundation is 9 kilonewton per meter square. Okay, so what is my delta sigma z? Delta sigma z is equal to 9 kilonewton per meter square. The groundwater level is at the surface. Okay, so the water level is somewhere here. Determine the consolidation settlement they are asking. Okay, so what is the formula? SC is equal to H naught divided by 1 plus E naught CC log of my initial divided by the initial vertical stress. Okay. So what is my initial vertical stress? Sigma V naught dash. So 9 into my submerged unit weight. What is the sigma V naught dash? How much? Tell me. How much?
73.71.
73.71. Okay. Now I have to calculate my delta sigma z. Anyway, delta sigma z directly they given. Due to the foundation loading, the stress in formation. Okay. So straight away you take my delta sigma z is equal to 9 kilonewton per meter square. This is kilonewton per meter square. Okay. Now, how to calculate CC value? CC value, because they given the liquid limit. So 0.009 into my liquid limit minus 10. Here liquid limit should be in terms of percentage only, you have to put that. So that equal to 0.009 into liquid limit. again, shit. I think again some network has gone. Okay, so are you able to get this answer? This 194 mm. Please respond, anybody? Priyashini?
Yes, sir.
So again, in meanwhile, we have lost again this network. I think. Can you tell me when you lost that network? Are you able to follow this problem? Whatever I solved.
Let's not see.
Oh, here, this one. Yes or no?
Yes, sir.
So how much consolidation settlement you got? Are you able to get this number 194 mm?
Yes, sir.
Yes. Aishwarya? Okay, so again, it's almost now 1 o'clock, so I will stop it here. So anyway, the PPT I have shared with you already. So you go through that PPT, and if you have any doubt, you ask me on Monday. So I will stop here.